All right, so let's take a look at our exponential function homework. Okay, so we are looking for the transformations for the first function. And so when I'm looking at my function, the negative in front always tells me that there was a reflection over the x-axis. So that's my first transformation. My second transformation was the 4 that's in the front. That tells me that there was a vertical stretch. So the number, since it was bigger than 1, tells me that there was a stretch of 4. And then there actually should have been a third transformation here because the plus 6 at the end is a shift upwards. So this was shifting up 6 units. And because the base is a number bigger than 1, 3 is the base and it's bigger than 1, that makes this function exponential growth. All right, for the next one, we have the graph going to the right 1. Because minus means we do the opposite of what our brain thinks. And then the plus 4 at the end here, that is shifting it up 4. So the number at the end of the equation tells us whether it's going up or down. And then lastly, if we look at the base of the exponent, since 3 is greater than 0, or greater than 1 rather, this is also going to be a growth function. So when the base is bigger than 1, it's exponential growth. All right, lastly, we have a 3 in the front, and so that's telling us it's a vertical stretch of 3. Then we have the minus 2 in the exponent. So that tells us that we shifted right 2 units. And then we have the plus 5 at the end, which tells us that it shifts up 5 units. And then to decide if it's growth or decay, I'm going to look at the base, which was 1/4. And since that was less than 1, this is going to be a decay function. Notice how 3 and 1/4 were not in my transformations. The base never goes in the list of transformations. It only tells us if it's growth or decay. So that's really important. Okay, so this function is going to go 6 up and 1 right. So since it's going to the right, that transformation gets applied to the exponent, and we do opposite of what our brain thinks. So we write -1. And since it's going up 6 units, we do that at the end of the equation, and we do +6. The next function started as 1/2 to the x, and it went left 2 units. And so that's going to be applied. Let me actually make my colors match. That's going to be applied to the exponent. And I'm going to, again, do opposite of what my brain thinks. And to go to the left, I'm going to do +2. And then we were told it was reflected around the x-axis. So I need to have a negative in front to show the reflection. For this one, the only transformation is that it was stretched vertically. So stretching vertically by 6 means that we need a 6 in the front of our function to stretch it. So 6 is the a value. And then the last one is shrunk vertically. So shrinking is going to change the a value. We're going to make that 1/2. And then it's also being shifted down 3 units. So up and down goes to the end of the equation, and we do not do opposite of what our brain thinks. So we just do -3. All right, so let's go ahead and graph this function. We're going to need to use Desmos to help us. So I have that open on my screen. So in the table, my x column is always going to have the same x values, -2, -1, 0, 1, and 2. And so I'm going to take the function, which is -2 raised to the power of x plus 1 plus 4, and I'm going to replace x with all of the values from my table. So I'm going to do -2, which gives me 3.5. Then I'm going to plug in -1, which gives me 3. And then I'm going to plug in 0, which gives me 2. And then I'm going to plug in 1, which gives me 0. And then when I plug in 2 for x, I get out -4. And then the equation of my asymptote is going to be +4. And I apologize, but I can't really get rid of this red line that's there. My asymptote should actually be at y equals 4, which is here. So this pink line is actually my asymptote. Ignore the red line. And I'm just going to plot the points that I got. So -2, 3.5, -1, 3, 0, 2, 1, 0, and 2, -4. And so if I look at this equation, it was growth because the base was bigger than 1, but it's going to be reflected because the negative. So my tail should be on the left because it's growth, but because it's reflected, it's pointing downwards. So that should be the shape that your graph takes. Tail on the left because it's growth, growing downwards, pointing downwards because of the negative in front. Let's do the last one. So again, -2, -1, 0, 1, and 2 go into the x column. And to find the y values, I'm going to take the function. And I don't know why, I always just type the x value in, like the whole equation first. Notice how I used parentheses around my exponent. If you don't do that, you are going to get the wrong answer. So you do need to use parentheses around the exponent. So I'm going to plug in -2 for x, and I get 48. I'm going to plug in -1 for x, and I'm going to get 12. I'm going to plug in 0 for x, and I'm going to get 0. Plugging in 1 gets me -4, and plugging in 2 gives me -5.3. So my asymptote is my k value, which is -6. So my asymptote is at y equals -6. Again, ignore that red line. I can't erase it. So I'm going to go to 1, 2, 3, 4, 5, 6. I'm going to draw my dotted line, and I'm going to plot these points. This point is way off the graph, but I can kind of do -112. It's going to be up here. And then I have 0, and then I have -4, and then I have -5.3. So right above my asymptote. And so this is decay because the base is less than 1, but it's not reflected because A is positive. So when it's decay, the tail ends up on the right. So my tail's here, and this is decay shape. It started really big, and it's coming down and getting small. So that is how we graph an exponential function.